All right, so we're going to move into chapter 6, which is going to deal with chemical reactions. We're going to talk about naming ionic and covalent compounds, which can get tricky and depends on how much time we get to do practice and how in depth we get. There's some general rules when it comes to naming compounds. Also talk about how they form, what likes to combine with what, and we kind of continue to move and build off of what we learned there in the periodic table unit. So what are compounds? So an example of a compound is table salt, which is sodium chloride or sodium and chlorine combined chemically. So it is made, table salt is made of two elements of sodium and one element of or one piece of chlorine. So when two elements combine to form a compound, the compound has properties very different from the elements that make it. So if we remember, we talked about table salt, sodium chloride. Okay, pure elemental sodium is a volatile metal that will explode in the presence of water. And then you have chlorine, which is a poisonous gas in its pure elemental form. But you put those two together chemically, and they calm down, so to speak, and they create a compound that all living things need, which is salt. So a chemical bond is the attractive force that holds the atoms or ions together. And a mixture substance or substances are just placed together. Each substance in a mixture retains its own properties. So that's the difference between a chemical compound or a chemical bond or a mixture. Chemical bond, you're changing what you started with. In a mixture, you're just putting a bunch of stuff together and stirring it up, so to speak. But they all keep their own individual properties, and they can be picked apart or separated a lot easier in physical ways than the chemical bond has to be taken apart in chemical ways. So when substances are chemically bonded, they form something new with completely new properties, and that's important to remember. So a compound always has the same chemical formula. For example, the chemical formula for water is H2O. The chemical formula for sugar is C12H22O11. Table salt is NaCl. A chemical formula tells you the types and how number of atoms making up the simplest unit of a compound. Man, I misspelled that bullet point wrong. So the chemical formula is going to tell you the type of atoms and how many of those atoms are going to be used to make the simplest form of that compound. For instance, in water, okay, H2O. H is hydrogen. The 2 after the H tells us that we have 2 hydrogen. O is oxygen, and there's not a number after it, so we assume that we just have 1 oxygen. So in water, you have 2 hydrogen and 1 oxygen. Water in a common in space or water in your cells will always be H2O. Chemical structure shows the bonding within a compound. So water's chemical formula tells us what an atom is made of, but it does not tell us anything about the way these molecules are arranged. Chemical structure describes the arrangement of the atoms in a substance. This is what we're talking about, the bond angles. We're really not going to get into this in this particular course. You do some in chemistry, but when you get to organic and inorganic chemistry, you really start focusing on bond angles, because the bond angles is going to tell you what type of structure it's going to make and how it likes to bond. And it gets, well, it can get complicated. It's not all complicated, but it can be. So two terms are used to specify the positions of atoms relative to one another in a compound. You have the bond length, which gives the distance between the nuclei of the two bonded atoms, and the bond angles. When a compound has 3 or more atoms, this tells you how they are oriented in space. So the bond length is going to be the space. This would be a ball and stick model of water. So the nucleus of, the hydrogen atom to the nucleus of the oxygen atom is going to be the bond length, and the angles at which they are bonded is going to be the bond angle. Models of compounds. So there's different types of models you can use. One is the ball and stick, and it helps us see a compound structure. Think of ball and sticks a lot like Legos. You put things together in a certain way and you build stuff. Then you have a structural formula. This is mostly the same as a ball and stick model, except that the chemical symbols is used. Typically, this is what's handwritten, okay? Even when we write structural formulas, we can still write them in the way that the bond angle is shown. Last one is space filling models. This shows the space that is occupied by the atoms. It's harder to see bond lengths and angles. Typically, this is computer driven. And this just basic goal is to show the relative size of the atoms in comparison to each other. So how does structure affect properties? We're talking about bond angles, and I mentioned that the angle at which these atoms bond is going to be important for their structures. So for instance, in quartz crystals, SiO4, every silicon atom is bonded to 4 oxygen atoms. These bonds are strong and are hard to break and allow for high melting points and high boiling points. Compounds with network structures are strong solids. Some compounds are made of networks of bonded ions. Like quartz, table salt, NaCl is found in the form of regularly shaped crystals. Crystals of salt are cubed shaped. The network is made of tightly packed positively charged sodium atoms and negatively charged chloride atoms. This causes a relatively high melting point and boiling point for salt. And you can see that the bond angles really kind of form this network that produces a cube, which is going to give us a very solid crystalline-like structure. Some compounds, however, are made of molecules. Salt and vinegar are very similar. Unlike salt and sugar are very similar. Unlike salt, sugar is made up of molecules. A molecule is made up of carbon, hydrogen, and oxygen. These molecules do attract to each other, not as strongly as the bonds between CH and O. So think about another molecule you think about is water molecules. Water does like itself, it is attracted to itself, but it will break off from each other. Attraction between water molecules are called hydrogen bonds. These bonds give water its elasticity. There is a weak attraction that holds each of these H2O molecules together, and this is why belly flop hurts, because there is when you land in water, jump in water, pour something in water, there are slight bonds that have to be broken between these water molecules before you can kind of dive through that initial surface of the water. And the reason this is highlighted red is because it was just a way to let me know that this is a stopping point for the first video. So be sure you complete the video form that goes with this. If you have any questions, let me know. Thank you.